Hello, here's one more example of how to graph a quadratic relation using transformations from y equals x squared. So when you're graphing using transformations, you want to make sure that you're applying the transformations in a specific order, because otherwise your final transformed graph may end up being incorrect. So when you do transformations, ideally you want to apply the transformations in the order that they show up in from left to right. The most important part of that is that you are saving the translations, so the shifts to the left and right and up and down, until the very end. So if you apply the transformations in order they show up from left to right in the equation, then that should happen automatically. So you want to make sure that any stretches, compressions, and reflections happen before any translations, also referred to as shifts. Right? And as long as you apply the transformations in that order, then you should end up with your final graph being correct. Okay, so for this particular graph, we are going to be graphing y equals -2 times x minus 4 squared plus 6. And we have these three values of a, h, and k in our equation that tell us what transformations are happening. So we have that a is -2, and that tells us that, well, the negative part tells us that there is a reflection in the x-axis. And the 2 tells us that there is a vertical stretch by a factor of 2. Okay, h in our equation, and remember again that in the equation in the general form, it's x minus h. So after the minus sign, whatever value follows that minus sign would be the h value. So here h is equal to 4, positive 4. And that tells us that we are going to be shifting to the right 4 units. And finally, we have in our equation k is equal to 6, and that tells us that we're going to shift up 6 units. So in this particular example, I'm going to do all of these transformations at once. So I'm not going to draw an in-between graph. I'm just going to draw y equals x squared and then one graph for the final relation. If you're not comfortable with doing this all in one step, that's perfectly fine. You can be following along with the examples in the other video I've provided with some examples of transformations where I show the in-between step when we have multiple transformations happening. But if you are comfortable, then you can feel free to skip that in-between step. So what I'm going to do is basically follow through this list of transformations in this order for each of the 5 key points that I've graphed for y equals x squared. If I do that, I should end up with the 5 image points that will give me the graph of the relation that I want here. So I'm going to start in the middle with the vertex at 0, 0. So if I apply a reflection in the x-axis, that would be multiplying the y value by -1. Or just thinking about if I use the x-axis as a mirror and reflect that point over that mirror, where would it go to? So here, because that vertex is on the mirror or on the x-axis already, a reflection in the x-axis doesn't change that point. Or if you think about it as a multiplication of the y value by -1, the y value here is 0. So it will remain 0 after we do that multiplication. Similarly, a vertical stretch by a factor of 2 is not going to affect this point because it has a y coordinate of 0. So the only transformations that are going to affect this vertex are these shifts. So I'm going to shift this vertex to the right 4, 1, 2, 3, 4, and up 6, 1, 2, 3, 4, 5, 6. And I end up at the point 4, 6, which should be our vertex according to this equation. Okay. So I'm going to move on to the point now 1, 1. A reflection in the x-axis causes that point to move here, right? I'm going to use the x-axis as a mirror. So the point 1, 1 is now at 1, negative 1. And a vertical stretch by a factor of 2 means I multiply that y value by 2. Right now, the y value of that point is negative 1. And if I multiply it by 2, it's now going to be at negative 2. So we'll just erase that in between point there. Okay, so that's not the final graph yet. I still need to take this point and shift to the right 4 and up 6. 1, 2, 3, 4, 5, 6. So the final point is here. Okay, next I'm going to look at the point 2, 4. A reflection in the x-axis puts that point at 2, negative 4. I'm just going to put a tiny dot there, and I'll erase the in-between dots once I get to the final graph. So we're at 2, negative 4. A vertical stretch by a factor of 2. Well, if I take the y-coordinate here of negative 4 and multiply by 2, I'm now at 2, negative 8. So another tiny dot goes there. And then if I take that point and shift to the right 4 and up 6, I get my final point is located here at 6, negative 2. Okay, so this gives me the right-hand side of my transformed parabola. Okay, we can see because of that vertical stretch, it's definitely stretched out vertically compared to that original graph. Now, I could either apply the transformations to these other 2 points on the left-hand side of y equals x squared, or I can use the symmetric properties of parabolas to get what those points are on the other side. So from the vertex, if the next point is 1 over and 2 down, then on the left-hand side, I can go 1 over and 2 down and plot a point there because that's symmetric to the point that's at 5, 4. Okay, similarly, the next point, I go from the vertex to the right 2 and down 1, 2, 3, 4, 5, 6, 7, 8 units. So from the vertex, I can also go to the left 2 and down 8 units to get this point. And then I can graph the rest of my parabola. And that's it. That's how to graph a parabola using transformations from y equals x squared by applying the transformations to each of the key points in order to end up with your final transformed graph. So I'm just going to label that with the equation y equals negative 2 times x minus 4 squared plus 6. The important thing with transformations is to make sure you don't get too frustrated with it. It is probably going to take you multiple tries before you're consistently getting the graph correct at the end. Make sure you're using some kind of graphing software in order to check your answers and make sure that you have applied the transformations correctly. And make sure you ask lots of questions if you are unsure about any of the steps of graphing transformations.